Hello students and welcome back to my channel. Today I am here to discuss questions from optics and modern physics which were asked in the second shift of 29th January 2023. So here we go. The first question is this. Given below are two statements, electromagnetic waves are not deflected by electric and magnetic fields. Students, this is true because after all electromagnetic waves are basically they are not charged particles, they are waves, and waves cannot be deflected by electric and magnetic field. Only the charged particles can be deflected by electric and magnetic field. So this is true. Statement 2 says the amplitude of electric field and magnetic field in electromagnetic waves are related to each other as this in the light of above statements. So this is wrong, students. Statement 2, because we know that speed of light is the ratio of magnitudes of electric and magnetic fields. They can be the amplitudes, they can be the instantaneous values, they can be the RMS values, anything. And as per Maxwell's theory of electromagnetic induction, C naught is under root 1 by mu 0 epsilon 0. So here E naught will be, the amplitude of electric field will be 1 by under root mu naught epsilon 0 into magnetic field. So you can see here mu naught is in the denominator, whereas here it is in the numerator. So statement 2 is false. So correct option will be statement 1 is true but 2 is false. So first option is the correct answer. Moving to the next question. A scientist is observing bacteria through a compound microscope for better analysis and to improve its resolving power. He should. Now, you see, resolving power is the reciprocal of limit of resolution. For a compound microscope, the limit of resolution is the smallest angle, okay, which should be subtended by the 2 points, okay, 2 point objects placed in front of the microscope so that they are visible as separate or they are just resolved, okay, and that is given as 1.22 lambda upon 2 mu sine alpha, okay. So this is the numerical aperture. 2 mu sine alpha is the numerical aperture and lambda is the wavelength. So limit of resolution is proportional to lambda. So in order to have more resolving power, we should have less limit of resolution. Less limit of resolution will require less value of lambda. So this is wrong. Wavelength should be decreased, not increased. Then coming to the increase the refractive index of the medium between the object and the object lens. Yes, this is mu is the refractive index between the object and the object lens, students. Okay. So certainly if mu is increased, limit of resolution will decrease and accordingly resolving power will increase. So the remaining two options will naturally be not absolutely correct. So we already got the first condition. Now moving on to the next question. Unpolarized light is incident on the boundary between two dielectric media whose dielectric constants are this and this. To satisfy the condition so that the reflected and refracted rays are perpendicular to each other. Now students, you should be knowing that in polarization, the reflected and refracted rays are at right angles to each other when the angle of incidence is equal to the polarizing angle between the pair of media. Okay, so that means this is medium 1, this is medium 2. Okay, so this angle should be equal to the polarizing angle. Only then angle of incidence should be equal to the polarizing angle. Only then the incident ray, sorry, the reflected ray and the refracted ray will be at right angles to each other. All right, this is a direct consequence of Brewster's law, by the way. And we all know that tan of polarizing angle, tan of polarizing angle should be equal to refractive index of second medium with respect to the first. Refractive index of second medium with respect to first, okay. So what is the refract index of second? So this will be speed of light in first medium upon speed of light in second medium. Okay, right. Now speed of light in a medium is equal to 1 by under root mu r into mu 0 to epsilon r into epsilon 0. In other words, c will be inversely proportional to the product of mu r and epsilon r. So here we have under root mu r into epsilon r for the second medium upon mu r to epsilon r for the first medium. Now in the question they have given that the for the dielectric medium mu r is 1. Okay, so this is 1, so you can just remove them and we are left with the ratio of epsilon r for second medium upon epsilon r for the first medium. Epsilon r for the second medium is 6.8, that for the second is 2.8. I have removed the decimal, students, okay, by multiplying numerator and denominator by 10. Okay, right. So therefore tan theta, I mean tan ip is equal to under root, we can cancel this by, I guess we can cancel this by 4. Is it? Yes. 4 sevens are, this will be 4 ones are 4 and 4 seventeens are. So this is 17 by 4 7, which can be written as 7 plus 10 whole divided by 7, which is actually 1 plus 10 by 7. So this theta is nothing but 7. So 7 is the correct answer here. Then moving on to the next question. The ratio of de Broglie wavelength of an alpha particle and a proton accelerated from rest by the same potential is this, the value of m. Now we know de Broglie wavelength is given by h by p, and since we have been informed regarding the energy of the particles because they have been accelerated from rest, so in that case momentum can be written as under root 2m k, where k is the kinetic energy, and also the kinetic energy acquired when a particle is charged from accelerated from rest is q into v. Since they are accelerated through the same potential, so what we can do is v is constant and 2 is constant, so we can write lambda varies inversely as root mq. That means the ratio of the wavelengths, Debye wavelength for alpha particle to proton will be under root inverse. So m and q for proton will be in the top numerator and that for alpha will be in the denominator. Okay, mass of proton is 1 amu, mass of alpha particle is 4 amu. Remember, alpha particle is a helium nucleus and proton is just a hydrogen nucleus. Charge on a proton is plus e, charge on an alpha particle is plus 2e. So we have 1 by root 8. So 8 is the correct answer. Then moving on to the next question. Substance A has atomic mass number 16 and half-life of 1 day. Another substance B has atomic mass number 32 and half-life of half day. If both A and B simultaneously start undergoing radioactivity at the same time with initial mass, this is initial mass for each, how many total atoms of A and B combined would be left after 2 days? So we have to find the total number of atoms for A and for B. Okay. Now total number of atoms will be number of moles multiplied by Avogadro number. Avogadro number I'll take it as Na. Here also same thing. Number of moles multiplied by Avogadro's number. So in other words, we require the number of moles so that we can multiply by Avogadro's number. Avogadro's number. Now number of moles is nothing but mass upon molar mass. Here also same thing. Mass upon molar mass. So we just have to find out the mass which is left at the end of what it is 2 days. Now molar mass of A is how much? For A it is 16. So 1 by 16 into mass of A remaining at the end of 2 days. See, initial mass is how much? 320 grams. And in 2 days, there will be two half days because half lives. Half life of A is 1 day. So in 2 days, there are two half lives. So 2 to the power 2. Similarly, for B, it is mass number, atomic mass is 32. Now, initial mass is again 320 grams, but divided by 2 to the power 4, because in 2 days there will be four half lives, because half life of B is given as half. So 2 divided by half is 4. So at the end of 4 half lives, it will be 1 upon 2 to the power 4, whole multiplied by Avogadro's number. Avogadro's number is 6.203023 into 10 power 23. So this should be the final answer. So 320 can be taken common, or if possible, let us cancel, not a problem here. 16 and 1 2 will get cancelled here. So we are left with 5 here. 32 10, and this will be 5 upon 8, because 1 2 gets cancelled here. So out of 16 into 6.023 into 10 power 23. So this will be, if you multiply 6 5s are 30 approximately, and this will be 6 5s are 30 by 8. 30 by 8 means 3 point something. Approximately 4. Approx. Okay. Into 10 power 23. So approximately it is around 34 into 10 power 23, which can be written as 3.4 into 10 power 24, because options are in 10 power 24. So this is the correct option. 3.38 is the correct answer. Okay. Then moving on to the next question. For the given logic gates combination, correct truth table is. So students, let us dissect it step by step. We'll write down the outputs. So here, as A passes through this, it becomes A bar, and B passes through this, it becomes B bar. So here B is directly entering, here A is also directly entering. So here we have A bar dot B, because this is AND gate. Okay, and here you have A dot B bar, and since this is OR gate, the end product is this or this, that is this or this. Okay, now this you cannot simplify, okay, by any simple formula. Of course we can simplify, but that is not a matter of consideration here. In such case, we can draw the truth table step by step. Okay, so what all things are required, you see. We require A, then B, A bar, B bar, A bar dot B, A dot B bar, and finally X, which is OR. Okay, so 0 0 0 1 1 0 1 1. So if this is 0, this should be 1, this should be 1. We have to invert it. A is 0, so A bar will be 1. B is 1, so B bar will be 0. So if it is 1, make it 0. If it is 0, make it 1. That's how we proceed. Now A bar dot B, A bar dot B. So dot means if both are 1 only, then result will be 1, otherwise 0. Similarly, A dot B bar, A dot B bar. If both are 1 only, then you will have 1, otherwise zeros. Now OR means at least one of them should have 1. So then the end result will be 1. So this will be 0. 1 or 0 is 1. 0 or 1 is 1. 0 or 0 is 0. So this is the end result. So let us check the answer. 0 1 1 0. So here we have 0 1 1 0. So second option is the correct answer. This is first, this is the third option, and this is the fourth option. So second option is the correct answer. Then moving on to the next question. The modulation index of an amplitude modulated wave having maximum and minimum peak to peak voltages of 14 millivolt and 16 millivolt is. Now, modulation index for amplitude modulated wave is amplitude of carrier wave minus amplitude of modulating wave upon amplitude of carrier wave plus amplitude of modulating wave. So here we have 14. Okay, sorry, this is, I'm sorry, these are the maximum and minimum values. Maximum value minus minimum value, here maximum value plus minimum value. This is the formula, you can check the formula in any of the books. So 14 minus 6 upon 14 plus 6, you can cancel with 7 by 2, to 2 sevens are minus 3, 2 sevens are plus 3, so 4 by 10, so it is point 0.4. So this is the option. Correct option is fourth option, second option. That's all in this video, students. Thank you so much for watching. Kindly subscribe to my channel and hit the like button. Thank you.